Hello everyone. So in the previous video we went over how to use this sensor here. It's an ultrasonic sensor. Now we're going to go over how to use this sensor, the TOF10120. This is a time of flight laser sensor, and because it uses a laser instead of ultrasonic waveforms, this sensor here is going to be a lot more accurate at detecting curved objects like a ball than this sensor. This sensor is only good at detecting flat surfaces, but this one here, it can detect curved objects with decent accuracy. But this video is going to be a little different because when we made the video for this sensor, we went over the methods used to create the controller. But because this one's a little bit complex, I'm just going to show you. It's just going to be a demonstration, and you guys can take the code and make basic modifications to it and use it in your projects. And yeah, you don't really need to understand it. It's already been built, but you can use it in your own project. So that's how it's going to be. And as usual, the code's going to be in the video description. But anyway, let's get to the demonstration. So this here's the code. It's actually a lot more simple than the previous one, even though the specification that it implements is a lot harder. But anyway, all this module does is takes a start. You have to wire these up. You're gonna have your measured value and your LEDs. Then you're gonna have your done reading output. And it's important to note that we need to have pull-up resistors connected to both the SDA and SCL lines with 4.7 kilo ohm resistors as the pull-up. And also know that the blue wire and the green wires are the ones that you use. So let's show you. Just give me a moment. Okay, so here we go. There's only 4 pins being used, and they are wired up as shown here. Man. So we got our SDA. Our SDA is connected to the blue wire, so the blue wire. So that means SDA is right here. And we got SCL is the green wire, so there's a green wire right here, connects to here, and then that goes into the second one. Yeah, and then the other 2 pins are just power and ground from black and red wires from the sensor. But anyway, let's get to the demonstration. Well, it's important to note that in this demonstration, there's a debouncer, but for your own code, you can get rid of that if you want. This is just so that I can get started with a button press, but obviously you can have me start from something else, depending on how you set it up. Okay. So, target. Moving the device. device. So I'm going to press this button and it's going to start displaying. So right now it's reading a distance from the roof, but if I put this book over it, you can see that the LEDs is in direct proportion to how close it is. When I bring the book up, it's a farther distance. Like, it's not easy to tell, but I'm right over the sensor. So the closer we get, the smaller the binary number. Then the farther away, the bigger. So that's that. And then when we get completely far away, it goes up to the ceiling. So yeah, that's the sensor. So the code is going to be in the video description. Like I said, you're free to take it and modify it however you want. Though this does have a debouncer, so you might want to, if you want to trigger it from something else, it's best to remove it. Though, once it receives a start pulse, it continuously starts measuring. So you only need to apply a pulse once. You apply a big pulse from a button press, then it will continuously start getting measurements. Okay. And you're free to modify this however you want. So you can like have it be where it takes, instead of it continuously doing it, where this done feeds into the start of this one, you can have it be where this done feeds into the start of another module that then creates another start done pulse like sometime later. So then you can take more time and that might increase the range, though you'd have to go look and see how the sensor works. But yeah, anyway, that's all for how this sensor works. So you're free to use this in your projects.